Thank you very, very much. So yeah, wrangling comes from the fact that in the browser, in JavaScript, it's all kind of the wild, wild west. So I'm Ryan, and let's talk about some large-scale front-end web applications. So the web is massively moving to the front end. Browsers are getting faster and better all of the time. The standards and technologies are exploding everywhere, and if you look at the ecosystem, particularly in open source, the velocity at which technologies change is just astounding. And I'm an ex-backend engineer, and I, now working a lot on the front end, I almost can't keep up with how fast it's evolving. On the user end of things, users want rich and seamless experiences. Waiting for page refreshes, a full page load of HTML is kind of like a thing of the past. Single-page applications deliver quick and slick experiences, and that's where things are heading. Product owners in your organization want fast and nimble applications, and modern JavaScript, for all of its warts, is extraordinarily flexible and fast to develop and iterate. So where we are now is that browser apps are what I would consider now business critical. JavaScript is not really optional anymore in the modern web app world. Does anybody remember the no-script tag? You can't really use that and get away with a modern web application anymore. And yes, that means even for the enterprise, even for very, very large companies. So what this means really is that JavaScript has won, for better or for worse. And we are destined for a web application of lots of JavaScript in the browser written by larger and larger teams. Each of these bullet points should in fact scare you because they're all kind of hard to deal with together, but at the same time present a great opportunity. So today, let's dig into some large traffic front ends at a high traffic top 5 e-commerce site. Specifically, I'm going to talk about my experiences helping out develop Walmart.com. And more specifically, I'm going to talk about, in this picture, the right side of things. The desktop and tablet site is a unified site. On the left, the mobile phone, the M-Web site, is a completely different project. So I'm going to talk about the desktop site and the tablet site. So why is this important? Well, the global e-commerce division of Walmart saw $10 billion in revenue in fiscal year 2014. This year, it's forecasted to be $13 billion. For e-commerce, your big, scary peak traffic comes over Thanksgiving. You have Thanksgiving, Black Friday, through Cyber Monday, that 4 or 5 day period. This past year, 2014, we saw 1.5 billion page views. And that's just an enormous amount of traffic. So what's behind Walmart.com right now? Well, there's over what I'd call 50 plus independent and discrete JavaScript applications bundled together and doing things like being the home page, being the item page. Behind that is over 650,000 lines of code spread across 2,500 files of JavaScript source. Now, Walmart.com currently has a Java backend, but there are now more JavaScript lines of code than there are Java. And that, for Walmart, is kind of a transition point that we're seeing across the industry. And I only expect this trend to continue. So the technologies that the existing Walmart.com site is built on are some familiar faces here to those of us in the front-end world: jQuery, Backbone, and _JS. The development team writing this code it's basically been a 2+ year rewrite. At one point or another, we've had over 50 engineers writing front-end code. Not all of them front-end only engineers, many of which were Java folks who just got shoved into, hey, you're going to do this JavaScript feature, but a very, very large team. And when I talk today about a track, Walmart splits its teams organizationally between the verticals, which would be product, cart, checkout, etc. They're all part of a common organization, but they have a little bit siloed organizational structure, and those are what we call tracks. And then additionally, within Walmart, there are many external teams and partners within the Walmart organization, such as the ads team, the SEO team, etc. So I'd like to take you on a tour through the trenches. Now, I work for a consultancy based out of hipster, rugged, cool Seattle, Washington, called Formidable Labs. We help teams from startups to Fortune 500 companies build full stack JavaScript applications. One of our largest clients is Walmart, and I'd like to talk with you about my Wrangling adventures as I am the JavaScript lead in the browser on the front end only for Walmart.com. And I've been there since the start of the redesign project over 2 years ago and kind of seen how things evolved and all of the kind of hiccups we've had along the way. And so what I hope to do today is talk about a few battle-tested tips from the field, which means that wrangling full large-scale front-end applications, the whole world of that is hugely complicated. I've spent 2 years doing it. So what I'm going to talk about is just a kind of handful of random tips of the things we did most wrong and the things that saved us when circumstances were most dire, kind of as a random smattering. And how I like to think about this is focusing on 4 kind of personas or ideas of what you need to do to keep your large-scale front-end application alive in production, and that is have some notion of architecture, guiding, gatekeeping, and lifeguarding. And so by architects, what I mean is that you need to plan and build a strong foundation for your large-scale front-end application. And what this means is what I'll call a real build. Now, JavaScript, you can just take raw JavaScript, place it on a page, and you're kind of off. But modern web apps are so complicated, you have to get some real infrastructure behind it. And second of all, code organization. How you store your source code, typically in a Git or other source control repository, actually matters. So our motivation here, and this is the fundamental challenge, is that JavaScript is the wild, wild west. And I love this image that we have behind us. What it is that is an experimental prototype jet plane, the X-1A, and that's a pilot. And he's wearing a cowboy hat and cowboy boots. And that just exemplifies modern JavaScript development, which is to say, extremely fast, extremely experimental, and likely to break. And so that's kind of what you're up against when you're crafting your front-end applications. So here are some of the fundamental challenges, particularly for those of you familiar with the back end, that are kind of nuanced and unique to the front end. First of all is that the browser is a single execution environment. You can't do microservices effectively on the browser. All 50 developers, all 14 vertical tracks write code that executes in the same place in the same runtime. More than that, writing your code, the size of it matters. How many bytes come down over the wire will have a performance impact on your application. On the back end, we don't really care about that. You care about how fast your code executes, not literally how large the file size is. JavaScript is hard to manage, easy to do wrong, because it's flexible to the point that's good in some instances, but it's flexible to the point that you get ad hoc decisions, spaghetti code, and all kinds of nonsense. And there's just kind of there's kind of a cowboy legacy to JavaScript. So when I talk about things being complex, let's just dive into one page, which is the Walmart.com homepage. And it looks like this. You've got a header at the top. We don't see it, but all the way at the bottom is a footer. There's a big ad for Black Friday, because that's what we're focused on at Walmart. And then the homepage actually has an application that does all that middle content. Altogether, there are multiple independent JavaScript apps executing in the browser. There is code executing on that page from 8 different teams. And this is what I'll call an exemplary in-transition page. It's not just like dynamic HTML with some JavaScript for buttons. It's got some real JavaScript logic there, but it's also not a modern single-page application where JavaScript controls everything. It's a bit of server-rendered, a bit of JavaScript, as kind of Walmart matures as an organization and gets into more and more modern web apps. So when we go on the page, it starts getting complicated. On the page itself, there are 28 script tags, 10 of which include remote scripts, 18 are inline. After all of that loads, we then download 6 more JavaScript files to do some execution. Of those on-the-page script tags, and these are the remote ones, 2 are our actual application code. They bootstrap us to get ready to do things like the footer and the header, but not yet. There are 2 CDN infrastructure files. There's 2 internal ads. There's 2 external ads, because hey, Google. There's one for the fonts. There is one Internet Explorer conditional polyfill. For those of you who do a lot of IE, you know why you have to have that, and it's, well, because IE. And then there are 18 inline scripts. Once we've done with that, we're ready to start actually doing the application code. And we do lazy code evaluation to get in the header. or at least the header above the fold parts, then the header deferred stuff, or the stuff you don't see, so that we can load the header first. Then there's the home page, which is the actual thing that we're trying to talk about. So of the lazy code, there's one shared library so that we can cache effectively across pages. There are 4 what I call primary entry points, the header, the footer, the home page. And there's 2 deferred entry points. So the takeaway here is, and this is why I brought all of this up, is it's complicated. I'm not going to go over exactly why all of those parts are there or how to craft that build, but just know that this is not our most complicated page on the site. And this is actually pretty par for the course or reasonable for an organization of Walmart's size with as many demands, external and internal partners as it has. And that is what you're up against. That's what I'm going to focus on. And your first step in just getting a handle on that kind of madness is what I'll call a real build. So modern JavaScript applications are complicated. JavaScript's like the only language that doesn't have an import natively. Anytime you start executing code, it goes into a global namespace. Horrible idea. So what has happened is that modern JavaScript applications have even more requirements too. You have to compress it. You have to you can transpile it, and what that means is take one version of JavaScript and make it into another. And then you have to do things like polyfills, because IE8, which is the lowest browser in our matrix at Walmart that we target, is missing a whole ton of functionality that needs to be there, and then you have to fill it in. So we have multiple JavaScript applications on the same page, and then there's this notion of what you do in development versus what you do in production with the full CDN, and keeping all of that sane, what you need to do is use a build tool. It doesn't really matter what you pick. I'm going to give you the most popular options here. The high-level takeaway, and my slides are online with the link at the beginning, and there will be another link at the end, is make choices from this list unless you have some extreme requirements. If you don't know these already, research these and make choices from this list. So there's 2 main paradigms for organizing your JavaScript, and that's a way to bring JavaScript up to where every other sensible language already is, and give it import statements. Make it so that when you include a file, you don't have to concatenate everything together, whether you use it or not. The paradigm and the organization scheme will only bring in the dependencies that you actually use when you bundle. So there's 2 main organization schemes. AMD, which is called the asynchronous module definition. It's a little more popular on the browser side. It's not used at all in the Node.js backend one. And then there's CommonJS, which is kind of like winning in the community. Then what you need to do is use a build tool or a loader, something to read your AMD or CommonJS organized code, and then make it into those big tortured bundles that are all compressed and minified and look like gobbledygook, but actually execute your application. The 3 main popular candidates are Require.js, Browserify, and the modern new kind of hotness, because Java is all about the new hotness, is Webpack. What I'd say is take some time to learn and evaluate the trade-offs. I'm happy in the hallway after this talk to just chat me up. I've had a lot of experience with each of these and can kind of give you a sense of the world. You want to pick from these lists if you don't otherwise know what you're doing, and that's how you organize your code. In Walmart, we try and keep up with things and evolve. So when I say legacy, that means the existing site. It's built on the AMD organization scheme and uses Require.js to be the loader. Our modern technologies, and I'll touch on this just a little bit at the very end, we are going the way of React. Since this is a largely back-end conference, that is Facebook's React.js framework, spelled R-E-A-C-T, not the big data store, R-I-A-K. That's where we're going, and React, the framework, is typically built on Webpack and with CommonJS. So we've even got a transitional world within Walmart where we are taking our legacy code in AMD format with our new code in CommonJS and putting it all together. This is a way of saying that, we have very complicated needs. The tools are pretty flexible, and you can transition from one to the next. So once you've picked your tools and you've got everything running, your goal is that both your production and your development builds need to be blazingly fast. In Walmart, there are some things we do very well, and there are some things that we could use some work on. Your goal here is in production, that JavaScript build of taking the raw source and making all these highly optimized bundles and available in the CDN needs to be fast because you will have bugs. And once you identify and solve the bugs, you need to be able to iterate, turn around, and redeploy quickly. In development, when JavaScript can get bundled, minified, things that can kind of take time, your developers will hate you and hate their life if that cycle between pressing the save button or typing in their integrated development environment doesn't have an immediate return of the actual code in their development environment. And there are many tricks and tips that you can get in there, which is the modern dev tools can keep all of the build like in memory. They don't actually hit disk. It's very efficient. Just know that these are your goals, and your prod build is probably going to be up to you to do right because you'll choose your own CDN provider, you'll choose how to upload it, but your development build, the tools should take care of you. You just need to learn how to make them fast and talk to your developers. Because when you get things off the ground and you only have like 10 files in your project, it won't matter what tool you're using or how you set it up. It's going to be blazingly fast. But for us, some teams will have to load 200 files just to run the app. It's going to matter a lot at that point how you architected the development build. The next point I would say is that you need to make your development build and execution environment identical to production as much as possible, because the differences will cause bugs. Over 2014 Thanksgiving period, we actually did remarkably well in those of us who pulled on-call duty for that during Thanksgiving, which was awkward for family and friends. We only had one significant bug on the front end, and that was that we do a simple switch of, in development, you get your static assets, which is your JavaScript, CSS, images, whatnot, off of the local system. But in production, you get them off of the CDN. And there is a helper we have that you have to wrap any instance of an image with that when it goes to production, it actually transitions and uses the CDN. More to the point, the static images on the dev server are not available in production. It's just a precaution because if you're like Tomcat or your application server serving static images, you're going to get hosed. So what we found is that we missed we missed 2 wrapper tags to say switch to the CDN asset. And that is one thing that you just can't see in development because you're not often doing development against the real CDN resources unless you're me writing the infrastructure. And so what I would say is we know that's a risk for us, and really the only bug we had was because it was a difference in how production and development works. Recently, we had to go through refactoring for PCI compliance, and there were a whole bunch of different architectural things that were up for grabs. And I can go into more details of what types of things we did, but the one we chose and that we spend a lot of time thinking about was the one refactoring that would allow development still to work exactly the same as production. And so really keep that in mind. Finally, and I'm not trying to scare you, but the other build complexities you'll need to think about as your code size and your team grows are sharing common code. Basically, you independently bundle up your applications, but you have this trade-off of the code either maintains multiple versions of jQuery, or I have to have this shared library first that everything else can share. And how do I turn that dial? When is sharing across, what number of shared across the 50 different applications we have is enough to go in the common? How do you tune and dial that up and down? The repository structure of where the code comes from impacts the complexity of the build. If you're using Node.js on the back end, how do you share the JavaScript code on both the front end and the back end? And that really is the future and where we're going internally forward in Walmart for new applications. And finally, I've just been talking about the application code your team is writing. There's combining in open source libraries and other third-party vendor code.
Sorry, Ryan.
Mm-hmm. Yeah, sure.
Hi, if there's anyone here from Vox Media, can you please come to the registration desk? There's been a situation with one of the folks. So, thanks. Thank you. Sorry.
Oh, no problem. All right, so that takes care of our first architectural point of get yourself a real build. The second one is code organization. And this one's much simpler, and actually, it applies to back-end and front-end projects, but on front-end projects especially, is you need to plan your repository structure. So I've already told you that the Walmart.com website has a team of 50 developers on the front end, probably the same number on the back end. When we started, we had one GitHub repository for the whole thing. Now, when you got the project off the ground, not a big deal, because we were only like 10 or 20 engineers. But as that project grew, it was painful. So much so that the dev environments slowed down. Once you get an enormous amount of files, how you actually store them on disk and how you slice up your organization in your source control management, and you should be using one, matters. What we've done is successfully split to 14 repositories now, each corresponding to each of the vertical tracks. And where we're headed for in the future is kind of like an internal open source paradigm thing of very, very small dedicated apps. Like the search team might have 4 different repositories that share and take dependencies on other subcomponents and compose those together. What you also need to have is a bias for small and flexible, because what you want to be able to do is deploy your front-end app at as granular a level as you can and make that whole, what I said earlier, that development experience all the way to pushing to production as fast as possible. So now that we've talked a little bit about organizing and structuring the infrastructure, architecting things, I'd like to talk about guidance. Is that with your front-end projects especially, and this matters more than back-end, is that you need to have some team and some notion of coordinating the chaos and leveling up the development teams. The things I'm going to talk about is, and I'll explain this more in a bit, is what I call a meta team. Then there's education, and then there's code review. So the guidance challenges are that you need somebody and some group of people, and hopefully most of your engineering team at one time or another thinking about the project as the whole. You don't have microservices in browser applications. Everything comes together and executes in one JavaScript virtual machine. You always need to think about onboarding unfamiliar and junior developers. There's a lot of JavaScript folks who aren't familiar with unit testing and modern development practices. There's a lot of back-end devs who get thrown into JavaScript in the front end. And finally, you need to help teams be consistent and complementary, because the JavaScript application really is this mega whole, even if you're writing it in parts and you want one part of it to read similarly to the other. So let's talk about the meta team. You have code from multiple teams all combined into one page, and that's the problem. What you want to think about is a team of engineers who represent the whole page. They're not so much, for us, the meta team isn't concerned about search or product. We're concerned about the web page. I'm concerned about the home page, the checkout page, and everything that executes there. So the meta team is just basically a group of developers and architects that set conventions and the best practices. They lead code reviews for consistency and DRY, which is don't repeat yourself. They develop common utilities and deployment infrastructure, and they're basically the coordination point for the project, and that's reflected because that's how a browser works. It's one execution environment, so you're going to have one team that's thinking about that. So the broad takeaway here is your task in your organization, once your front-end web application gets beyond a certain size, is have a meta team. So at Walmart, our what we call the Meta.js team is basically 1.5 dedicated developers, a part-time dev and a full-time dev, which is myself, that only work on Meta. I only think about the entire project. Then what we have are 6 what I'll call loaned developers from the various tracks, that their tracks donate the developers time, say 1 day a week, to do code reviews or something, so that we just have a larger pool to pull from. Basically, our Meta.js duties entail about 1 day a week of code review, where you are the code reviewer for Meta for that day. Chat channel participation. We, like so many others, use Slack internally in Walmart. Side note, Slack is eating the world. At Formidable Labs, every single one of our clients, plus Formidable Labs itself, all use Slack. So it's a great tool. It's a great communication means. And for Meta.js, that's our primary way of interfacing with developers, because on the Walmart.com project, there's a good nexus of developers in San Bruno, but it's pretty much a fully distributed team across the entire world. And then our final duties on Meta.js are what I call cross-track JS initiatives. Things like internationalization. You need infrastructure and you need rollout and education. and that's not just something for the product team or the checkout team. It cuts across all of the verticals. So the benefits of having this team, and especially you need to know the benefits because when we're pitching it, we have to go to project managers and say, I need one of your star developers to dedicate about 30 minutes to maybe 2 hours one day a week just to help out the project as a whole. So these are what the takeaway benefits are if you need to sell this internally in your organization. First is that you have project-wide consistency and support. And again, that matters. All the code comes together. You don't get to isolate your JavaScript code. Second of all, is it's a good way to help tracks consider other teams. Because when the product team does something, and say it impacts the global namespace, you have to, for some reason, do something on the window dot variable. If you execute in the same, if it's a combined widget with some other team, you can impact what's happening across tracks. And you need the tracks to start being more cognizant of what my team does will affect what happens in that other team's application. The flip side of that, it's a great way to represent the track interest in the core. And that's kind of how I pitch it to like the product manager, is that product now gets representation in the core of the whole project because you have product developers helping out the meta team. And finally, you get to spread knowledge around and have more engineers who can just wrangle the project as a whole. And that's a very, very good thing because we have a bit of a bus factor problem with my role on the current site where just I know a lot of the kind of arcane, bad, horrible details that are probably my fault. But with the meta team, there was more of a fighting chance of developers who will be familiar with at least some aspects of that. And it's a good way to just help reduce, if not eliminate, bus factor. So let's transition on to education. This goes across front-end and back-end, but what I'd say is continually write living documentation and close to the code. For us, a lot of folks, for one reason or another, are unfamiliar with modern JavaScript practices. Some of them. Many of them are unfamiliar with how we do JavaScript for the particular application that comprises Walmart.com. So we try and write as much documentation as possible. And what I'd say is a good heuristic is anytime you're answering a question about how does this work, or it's something fundamental, or why do we do it this way, if you've answered that question 2 or 3 times, the 4th or 5th time you answer it should be with a pasted link to the internal docs, ideally that are in something like Markdown in the GitHub repository that you have. What I'd say also is take a hands-on approach and have a notion for certain topics. So unit testing is something we all know and love on the back end. In the front end, it, for a while, was really, really painful. Even as recently as 5 years ago, unit testing in the browser was just horrible. It's getting much better, but most JavaScript front-end devs aren't that familiar with it. So at the beginning of the Walmart.com project, we invested a lot of time in putting together a test infrastructure and teaching devs how to do unit tests. And what that meant is the meta team actually would jump in. We would jump into a branch, we would pair up with developers and help actually even write skeleton code to get teams more familiar with how to write the tests, how to execute them. And in code review, we kept insisting on this and put in a lot of work. What I noticed was about a year into the project, we weren't helping many people. And as new devs came on, we weren't helping onboard the devs and test. What had happened was the track leads in each of the various tracks had gained enough knowledge to learn how to do unit tests that they were actually able to take it back to their teams. And that's what I mean with take a hands-on approach. You couple it with this next slide, which is you invest in rising developers, those folks who can basically take the knowledge and spread it across the development organization and back to the teams. Now, the final leg of what you need to do in guidance is code review. So at Walmart.com, every single line of application JavaScript gets what I call substantive and meta review. Substantive review means your code gets reviewed by somebody on your team who actually can tell what it does. Like the product team reviews a product widget and says, yes, it does do the color switcher like it's supposed to. But all code also gets a second review from the meta team. And that is just the meta team looks at it and says, is this idiomatic JavaScript for our project? We usually do the will this break IE8 because that's usually the thing we find a lot. And then we say, will this have any other side effects or dangers across the project? And what I can say is it's taken some time to do this, but we have caught so many bugs in the track and meta reviews that never even made it into the master branch, let alone at QA, which is expensive to find a bug, or heaven forbid production, when it's really, really expensive to find your bug out there. What I will say is we also have a meta CSS team and a meta Java team, and our horror story, which I can go into more detail in perhaps the hallway, is we had a really, really unfortunate incident where some Java code under pressure went to the release branch, missed the meta review, and the release branch, through timing coincidences, got immediately cut to production, went out to production, and then category pages over a certain integer number started breaking because there was an invalid assumption about what the maximum value could be for the integer. And that's a canonical case of something that the meta team can think about. They're not so much concerned with what the code does, but on the Java end there, it would be a consideration of, I see an assumption that the integer can't be over this value, when in fact in Java it could be this much higher value. And in fact in Walmart's database it was that much higher value. So have your meta review. Find your bugs early rather than in production. And what I'd say, especially for JavaScript, is this includes all third-party code. And that means internal to the organization, like say we take in like internal ads JavaScript, or third-party external to Walmart, like some vendors. My horror story here is an unnamed vendor has an enormous analytics library. We demanded the unminified raw source, and we do this pretty much for every vendor that we have. It was 15,000 lines, enormous to go through, but we still went through the entire file. And what we found in there was it patched the JavaScript runtime. It patched one of the fundamental things, event.prototype.stopPropagation. And I don't even know how we found this, but we did. It would have caused that to not work at all. Now, I won't go into the super technical details, but I can tell you this is your horrible nightmare if you're an architect like me, because if event.prototype.stopPropagation stopped working on Walmart, it wouldn't be immediately apparent. It would be buggy, but it would be buggy in ways that would not be obvious if all you were looking at was the code going wrong in production. The fact that we found it in code review really underscores that that would have been a vendor library. So it was not even on our radar otherwise, where normally you just say, oh yeah, include this. Like, for example, we do blindly include Google Analytics because we trust that Google has done enough software testing of their stuff that Google Analytics won't do something like patch event prototype. But for all of the other vendor code, pretty much that's not Google, or that we serve from the same domain as the Walmart code, we review all of it. And because same browser environment execution, which I keep hammering, it changed how JavaScript worked. That vendor library changed how the fundamental JavaScript worked on our page and would have broken us in some really, really bad ways. And basically, after that one, we got really, really stringent about our vendor code requirements. Which brings me to gatekeepers. You need people to protect the front end through both process and architecture. How I like to think about this is you need to automate your quality. You need to minimize the risks and exposure. And on the front end in the browser, there are many. And finally, you need to require performance. So the challenges here, organizationally, is that there is feature pressure. Ideally, you want to do everything right, consistent, and in a speedy way. But what ends up on the Jira ticket boards are feature, feature, feature. And that's what the PMs are usually incentivized to drive. That can often lead to poor code quality. And then there's also some other risks of, at least in Walmart, and probably on many of your sites, there is JavaScript code that will execute that you've never seen before, never heard before, and can possibly get injected at runtime. That should scare you. So first of all, in your own code, you automate quality. There is a first level of static checking. Tools like ESLint, JSHint, JSCS can enforce convention and can find low-hanging fruit, just bugs, straight up by running them. This is the low-hanging fruit because you essentially define your rule set of what you want to assert on your JavaScript code. You turn it on and run it over the source. You don't have to do anything else. It is so easy. You must do this because you don't have to even write tests. You just have to set up the tool. Pick one of these. ESLint's the most modern and fully featured. And statically check your code. Research what these tools can do. But this will give you one easy way of instant code quality once all of the code passes all of the checks. Second of all, there are client-side unit tests. that is taking your code in isolation, one small part, executing it in a browser environment. And modern tools like one called Karma can spin up all the browsers on your desktop. It can hook to a vendor like Sauce Labs or Browser Stack and run in VMs, like anything in your browser matrix, any combination of OS, browser, and what have you. And then there's the familiar integration and end-to-end tests where you wire up the whole application, usually drive this with Selenium because I think the Winston Churchill quote is, Selenium is the worst form of unit integration testing except for all others. It is the one that has stood up the test of time, and it's just a hard thing what it's doing. Between your unit tests, which are fast to write and run but very brittle, and your integration tests, which are slow to write, very slow to run, but pretty much the real deal, together what you should be aiming for is some notion of code coverage. That together you want to be, your goal is to execute most of your code in your branches before you even hit master, because that is the cheapest time. It costs you the least amount of money and developer time to catch bugs there. At Walmart, we actually have a 70% code coverage threshold for all of our JavaScript code. The main reason we pitched this is because the JavaScript code we have doesn't execute in our own servers. It executes on browsers in places we don't understand. So we want to, in our environment, require that it get executed at least once. We've also set up a situation where code coverage just as a straight metric is just kind of meaningless. It's just a number. It sometimes doesn't make sense. And demos happen, deadlines happen, bugs happen. Devs can't just blindly always meet the 70% threshold. So what we have is a system where you purchase a code coverage exception by opening a JIRA ticket that says, I will write the tickets, I will write the tests, and then hopefully that goes into your next sprint. And that's our kind of heuristic for saying the enforcement mechanism doesn't have to be so rigid that you can't get around it, but we at least capture the technical debt when folks do get around it. And the final thing, and this is why it is truly a gate, is you hook all of these things, your static test, your unit, your integration tests, into a continuous integration system that runs for us on every branch and pull request that we open up, so that we see you need to have a green CI before you can go into master. It gets run again on master before we go to our staging and before we go to our production deploys. And that's a way of investing in all of these checks and having it be a firm gate before you get out to QA and then production, where things get much more expensive to fix. So the next thing is you've done all of your housekeeping. You've got your unit test, you've got everything set up. What you need to do is then actually look broadly and think kind of creatively and horrifically of minimizing the risks. And what you need to do is learn and identify your biggest risk areas and then protect yourself wherever possible. So this is going to be specific to your application and your organization. I'm just going to talk about 3 classes of risks that have bit us in Walmart.com and how at least our biggest scary points. One is what I call architectural risks. One thing that we have in Walmart is, so we've got this rigorous 70% code coverage threshold, static checking. We actually use 2 different static checkers. For all the application code, it goes through QA and goes to production. That's a lot of process and a lot of eyes on that code. There is, however, some of our ad code that comes from partners last minute and is written by a different team, and through a lot of weird business constraints and the fact they're not part of the organization that's responsible for Walmart.com, it basically goes, developer writes the code on the laptop, it goes straight to production. So this is obviously a huge, huge risk, and it is our #1 source of front-end errors. So what we have done is, there's enough revenue and value in having this system that we have to tolerate it, but we do things like isolate that code to execute in an iframe. In some instances, we even host the JavaScript from a different domain, so it has different sandbox privileges from our existing one. And that won't stop all classes of errors that my team gets called up for on call, but it's at least knowing and identifying and protecting where we can. And then we also, as part of our on-call playbook, know to turn that off as one of our first steps if things appear to be weirdly going wrong in a way we can't figure out. The next type of risk for us is a code pattern risk, which is, and we have many anti-patterns. In JavaScript, there are so many opportunities for anti-patterns. This is one of my favorite anti-patterns. It's called defer and pray. If we read through this code here, let's assume that step 1 has happened. But step 1's asynchronous, and it might do something on the DOM, it may wait for a callback. I don't know, it's going to take some time. So I'm going to set the variable, hopefully enough time to be 2 seconds, because it should be done in 2 seconds, I think. Then I'll set a timeout and I'll wait, and then I'll go for the next step. This type of code, oh man, it bites you so much, because generally speaking, your development environment's so fast, so that'll pass. If that happens in your test will probably still pass. And then it goes out into the world of the different browsers where latencies and how long things take to execute, IE8, will be drastically different, and then it breaks. So we don't have a great way of statically or automatically checking it. Part of the meta team review is looking for anti-patterns like this and trying to catch it as much as possible in code review. And everyone knows, defer and pray is such a common phrase used in our code reviews that we're pretty good about educating teams not to use it. And finally, the type of risk I'd like to talk about is process and organizational risks. So many of us are familiar with the notion of once you go to prod, and you've got prod running, you go through your next release cycle sometime down the way. In the meantime, the only thing that goes to prod are bug fixes, or what you often call hot fixes. Well, a lot of times, organizations and product owners and stakeholders have so much pressure for features that we end up in these kind of awkward situations where we have pressure to do what I call hot features, which is a huge chunk of code that's going to be cherry-picked from the master branch and tried to push straight up to production. I wish I could say that you can always shut this down. This is more something for us that we're mindful of, and we really push back unless it's something so critical. I mean, there's a dollar value to everything, and then for us, we assess the dollar value risk of things breaking versus the dollar value risk of having the feature out. Generally speaking, try to avoid this. You're introducing way too much risk in your process. Try and go through real release cycles. Okay, the final gatekeeping point is require performance. So front-end code has to be both small and fast. But teams are feature-driven unless performance is enforced and required, because it's really easy to add features. It's really easy to not think about. In JavaScript, you have to think, I've got 2 things I want to have happen. I've got 2 different classes, foo and bar. You really need to abstract that to a common class to keep the code as tight as possible. And that's not that easy, because it performs the same, but what your target is that minified code needs to be as small as possible. And that's hard to do, and that's going to take you more time than just writing foo and bar and more or less doing kind of an almost copy and paste between the two to get your feature out the door. And the hard part on the Walmart.com project is we did not do any performance requirements except for within the past 6 months. It was pretty much feature-driven, and now we are having a rough road trying to get back on track. Now, we've done enormous efforts at the infrastructure level, and we have got an entire performance team, and we are what I call putting the teams on a diet. What I would have done if we could do this from the start is, first of all, enforce with audits. Patrick gave a wonderful talk yesterday at Surge on web app performance, measurement, monitoring, and resiliency. Web page test is one fantastic tool that Patrick is a part of that measures and will make you feel sad and unhappy about how your site is going, but you need to periodically run these tools and have a team looking at the results. You need to enforce with process, and this is the thing that we totally missed early on that I would encourage you to do, is have performance metrics from those audits be tickets on your actual sprints next to the features. Because if they aren't visible at that level, PMs will say, no, we just got to get the features done. Devs will say, it's not my ticket. I'm not going to work on performance. Make it something that is a first-class citizen in your ticket and your organizational structure of doing perf work. And finally, enforce with automation. I've got a link in the slides to automating web performance measurement. It was a great talk at this year's Cascadia JS conference of taking performance tools and having them automated from the command line, and then you hook them into CI. Now, there's some limits, and perf measurement's a bit wonky, as Patrick's talk eloquently goes into. So you can't do everything here, but have at least some gates for saying your code size can't increase beyond this certain amount in a pull request. Your code cannot perform like abysmally horrible in a way that if the automated tool catches you, you're doing something horribly wrong. And have that be your first stop, because again, automated things, as long as they're not oversensitive, are a great place to catch potentially lurking issues, and in this case, performance bugs.
And finally, I'd say, and this is the hard part, build your own tools when necessary, because our build is now complex enough that we have to write our own tools to introspect it for the developers to even understand what's going on, which is hard because the code and dependencies are just big. Our final theme here is lifeguards, and that is you need to create escape hatches and lifelines in production. I'm going to talk about logging and monitoring and debugging helpers. The challenge is, again, code executes on different browsers out in the wild. When you have an error, it's not on your machine running in your logs in an easy-to-capture way. So logging and monitoring is the first step here. Your code runs, and most importantly, it fails in a whole variety of browsers and operating systems out in the wild. So what you need to do is log and capture everything. And yes, I mean on the front end. So there are many tools to help you do this. What you want to do is do warning or error messages and capture any thrown errors and get them off the browser and into a remote storage that you control. Then you aggregate, report, and alert on those. Here are 4 basic providers, Rollbar, Loggly, Sentry, and Airbrake. We use Rollbar in Walmart. And what I'd say is the aggregation is key because stuff goes so wrong, even if your code's probably right in browsers, that you need the aggregation to say what is horribly going wrong the most, and we'll focus on that and winnow down from there. The last thing I'll talk about architecturally here is debugging support. And this is an astronaut out above the world with just a single line tethering him back to the space shuttle. You need to give your developer lifelines when things go wrong. Here's one of the hardest things. You have a bug in production, you call up the developer and say, go to work on this. Well, you ship this code. Minified, it looks like gobbledygook. I've got var E means something. I've got var A probably means something. And poor developer, he gets woken up at 3 a.m. and has to figure out what's going on. Your developers wrote, and they want to see something like this. That's variable message, variable heading. It's intuitive to the developers. Fortunately, modern browsers have support for what's called source maps, which is the last comment in the minified file that we serve up has a link to a mapping file that works just analogously to C or C++ source maps, where the minified code loads, and then the source map is downloaded, and developers can, off the minified code, actually debug through the unminified code because it's mapped. And so this is a huge tool that you should enable for your developers to always be enabled in production. But the one caveat here is the source map contains the unminified source, which you probably can't distribute publicly for keeping your intellectual property and keeping your secret sauce actually secret. So what we do in Walmart is we publish within the VPN on deployment, and the source mapping URL hits an internal URL. So our source maps are actually hidden from the end users, but any Walmart Labs developer, upon coming into the VPN, can get access to the source maps and debug off the source maps. So we get the best of both worlds. So that's a lot of points we'd covered. Putting it all together, it's basically have a real build, organize your code sensibly, have a meta team thinking about your whole front-end application. You need to do education and code review, automate the quality to make sure it's good, minimize your risks, and please require performance, and finally log, monitor, and give some debugging lifelines. In the waning minute or so I have, I'd like to give some parting thoughts on the future. So that's Walmart.com right now. Where are we going? The first thing I'd say is you need to embrace change. JavaScript moves ridiculously fast. I mean, it's not even so much a joke to say, oh, that was like 2 weeks ago. So React, which I've got the symbol here, is so cool. It offers so much new flexibility that we as an organization are trying to really experiment with that at Walmart. But it's painful, it's uncomfortable, but what I consider necessary. Not only your frameworks, but reevaluate and refactor your infrastructure and the organizational structure. This is the Webpack logo. We're moving from Require.js to Webpack at the infrastructure level. And finally, please have a transition strategy. We've had some bad experiences in the past on our Walmart contract of having developers need to just full stop and switch to something new. I can tell you on big projects that doesn't work, or it doesn't work well. Have some notion of spending extra time to allow you to take your old code and make it into your new code. And with all of that, I'd like to wish you happy wrangling and say thank you very much for your time.
Knock it louder, sugar. Bang.
Okay. There is a microphone up front if you want to step up. Otherwise, I will repeat your question for the audience.
How did you deal with dependencies on one team working on a feature or enhancement that another team may have been working on?
Okay, so the question is, how did we deal with dependencies between the teams? What we basically did is there is one common, I guess I'll use the example of the product team. The product team either writes in what I'll call the product namespace, which is their own code and they do whatever they want, or there is another namespace, which is a shared repository where it would be common/product, which is they write common code, and that is expected to be shared across the tracks. And so basically, we just organizationally distinguish what is your common code that you're going to share and what is your internal code. From there, any team can take a dependency on common, but teams can never take what I call cross-track dependencies. Product code cannot depend on checkout code, and that's kind of the just organizational way we slice and dice our dependencies. All right, just got dependencies. Well, I will be available in the hall to talk about any of the nitty-gritty details, and thank you all again.